Welcome to today's lesson on irrational numbers. So far in this unit, we have studied integers, whole numbers, and natural numbers. We have learned how to express rational numbers as fractions and as decimals. Today, we will learn about irrational numbers. Are you ready, students? Let us begin the lesson. Please look at these numbers, students. Using what you have learned so far, work with a classmate and identify the rational numbers. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Last time, we learned that terminating and repeating decimals are rational numbers. So, we know that A and C are rational numbers. What about the other numbers? The square root of 16 is 4. So, we know that E is a rational number. If we tried to calculate the square root of 5 using a calculator, we would get a number like 2.2360 and on and on. The decimal number for the square root of 5 does not terminate, so B is not a rational number. Likewise, D is not a rational number. What about F? This decimal has a pattern that neither repeats nor terminates. It is not a rational number. From this exercise, we can make the following generalizations. A decimal that is neither a terminating nor a repeating decimal is an irrational number. Roots that are not perfect are irrational numbers. The formal definition of an irrational number states that it is a number that cannot be expressed as A over B when A and B are integers and B does not equal 0. The most well-known irrational number is pi. Pi is often represented as the fraction 3 1/7, or as the decimal number 3.1416. But these are only approximations of the value of pi. Some mathematicians have calculated the value of pi to over 1,000,000 decimal places. Students, we are now going to learn how to locate irrational numbers on the number line. Do you think this is possible? There are infinite rational numbers. Perhaps rational numbers fill up the number line and leave no room for irrational numbers. Let us see. We will plot the square root of 5. Our first step is to find two numbers whose squares have a sum of 5. Since 1 squared plus 2 squared equals 5, we will use 1 and 2. Now, we draw a number line. At the point labeled 2, we draw a perpendicular line that is 1 unit long. Next, we draw the line segment from 0 to the top of the perpendicular line. We will call this line C. The Pythagorean theorem tells us that C has a length of the root of 5 units. We open a compass to the length of C and draw an arc that intersects the number line. The distance from 0 to this point is the root of 5 units long. Students, please find your partner from the first activity. Work together to locate the square root of 6 on the number line.
Students, let's get ready. Let's get back to our lesson.
Hello, students. How did you do? Two numbers whose squares can be added together to get 6 are 1 and the square root of 5. Since we just learned how to plot the square root of 5, this should be easy. We mark the point on the number line that represents the square root of 5, and we draw a perpendicular line 1 unit long. From 0, our arc passes through the point at the top of the perpendicular line and crosses the number line at the square root of 6. Does your number line look like this one? If you had any trouble with this exercise, please ask teacher to look over your work after the lesson. Another rule to remember is that the sum of a rational number and an irrational number is an irrational number. To prove this rule, we will use 4 plus the root of 7 If we assume that this is rational, then we must be able to express it in the form of a over b. The root of 7 equals a over b minus 4, or a minus 4b over b. Since a minus 4b and b are integers, then this fraction is a rational number. That means that the root of 7 is a rational number, which we know to be false. In fact, the sum, difference, product, and quotient of a rational number and an irrational number are all irrational numbers. Now that you are familiar with irrational numbers, please look at these numbers and identify which are rational and which are irrational. Go ahead, students.
Students, let's get ready. Begin. Let's get back to our lesson.
Hello again, students. I am sure that you found that exercise much easier than you would have at the beginning of the lesson. The square root of 0.49 is 0.7. This is a perfect square, so a is a rational number. Although both of the numbers in B are irrational, their sum is the repeating decimal 0.7. So B is a rational number. 3 over 16 is a fraction of two integers where the denominator does not equal 0. So C is a rational number. Neither D nor E are rational numbers. They are irrational. Students, we have learned that a decimal number that is neither terminating nor repeating is an irrational number. We have also learned that roots that are not perfect are irrational numbers. Finally, we have learned how to locate irrational numbers on the number line. That is all the time we have for today's lesson. Until next time, thank you, teacher. Thank you, students.